Hello, welcome to my series on computer science and computer science integration pedagogies. My name is Yu Hongsun. I'm one of the MLTI 2.0 ambassadors. My job is to work closely with the Moodle digital learning specialists and the other MLTI 2.0 ambassadors to provide instructional technology coaching, create and deliver professional learning. This is me in my Bitmoji. I'm very excited that you could join me in exploring some of the effective pedagogies in teaching computer science and integrating computer technology into K-12 curriculum. Over the past decades, there has been an increasing research on computer science and computer science integration pedagogies in K-12 education. Data shows that certain teaching methods are more effective than others for computer science and computer science integration. The theories will explore the popular pedagogies for computer science and computer science integration, such as computational thinking, contextualized learning, collaborative learning, and learning away from the computer. The series will use examples from the teachers of computer science and other disciplines and discuss which teaching methods and pedagogical approaches are effectively used in the classroom and how the teaching methods support the learning processes and prepare students for the 21st century job market. Here are the topics. Topic 1. Computational thinking skills development. Topic 2. Engaging students through contextualized learning. Topic 3. Building critical thinking and problem-solving skills through collaborative learning. Topic 4. Cultivating computer science and computational thinking skills by teaching away from the computer. Today's topic is building critical thinking and problem-solving skills through collaborative learning. It will cover pair programming, peer review, group work, learning by teaching, problem-based, and project-based learning. In the computer science industry, collaboration is particularly important because computer scientists or software developers need to share skills and solve problems together. Collaborations often provide computer scientists or software developers with the opportunity to work on new problems they might not even consider when they first start a project. Sometimes collaborations can even change the directions of their original design. Collaborations also help reduce human errors and increase the quality of work. In real workforce, people with different knowledge, skills, and expertise always collaborate and coordinate to get things done. Since collaboration is so important in the computer science field, computer science teachers should prepare students with those collaborative skills and be acceptive to the collaborative learning method. Collaborative learning is not just breaking up into small groups. What is collaborative learning? According to Barbara Smith and Jane McGregor, collaborative learning is an umbrella term for a variety of educational approaches involving joint intellectual effort by students or students and teachers together. Usually, students are working in groups of 2 or more, mutually searching for understanding, solutions, or meanings, or creating a project. Simply put, collaborative learning is a learning method in which 2 or more students learn things together and solve problems together. Collaborative learning is an active learning process. It consists of 2 parts: learning by constructing knowledge, and learning by working with others. Students learn by sharing their knowledge, by teaching others, and by solving problems together. Collaborative learning is student-centered. Within this model, students take and share responsibilities for learning while teachers coach, guide, help select partner, structure groups, and provide feedback. Collaborative learning can occur in pair programming, peer review, or group work, and is closely tied with learning by teaching, problem-based, project-based, and computational thinking. In computational thinking approach, a problem is systematically decomposed into smaller parts, which is itself a problem-solving approach. Collaborative learning involves sharing skills and resources, pulling knowledge and skills together to analyze problems, design solutions, which makes it possible to attempt more complex and difficult tasks in ways not possible by individuals working alone. In this video, I'm going to explore how pair programming, peer review, or group work are implemented in computer science classrooms to build students' critical thinking and problem-solving skills. Pair programming. What is pair programming? How to implement pair programming with problem-based learning. Examples of pair programming. What are the benefits of pair programming? What is pair programming? Pair programming is a software development technique. Two programmers work shoulder to shoulder at one computer to design, code, and test. One programmer is called driver. Driver controls the keyboard and writes the code. The other is called navigator. Navigator oversees the programming and reviews each line of code as it is typed in. The two programmers switch roles frequently. Pair programming is a collective effort for completing a task because two programmers continuously communicate and collaborate on the same design, algorithm, code, or test. They produce a higher quality work, and there are few mistakes in their project. Many tech companies use pair programming, such as Facebook, Peloton, Snap, etc. In computer science classrooms, pair programming is a collaborative learning method in which students program in pairs. Pair programming is regarded as an effective teaching method to develop students' critical thinking and problem-solving skills, and is frequently used in classrooms. It works basically the same way as that of computer industry. Two students share a computer, taking turns as the driver and the navigator, switching roles frequently. Pair programming is student-centered. Students work together. They share knowledge, communicate, collaborate, learn by teaching. They switch roles frequently. Teacher's role is to direct students in the right direction, monitor students' work, provide help and coaching. How to implement pair programming? To implement pair programming, we need to design an appropriate project for students, set goals for the class, set rules and boundaries, select a partner, decide how often students need to switch roles, teach students to respect each other's opinions, work together, and review the work together. I usually design a shorter assignment, about 1 hour and 10 minutes, to complete. I explain and present the assignment for about 10 minutes, including goals and learning points. Then, have students select a partner. Once students are paired, I further discuss the rules for the project. For example, how often do students need to switch roles? In my class, I usually let them switch 2 to 3 times per 70 minutes to make sure the stronger student does not dominate the whole exercise. After that, students choose a computer and begin to work together. I walk around to help and monitor students' work and to ensure students are on the right track, engage themselves, and complete the work on time. Strategies to pair students. To select a partner is an important step in pair programming. There are a few options. Teacher's choice. Teacher pairs students based on students' intellectual levels, sometimes with the same intellectual levels. Sometimes one student is stronger than the other. The intention is for the less stronger student learns from the stronger one, while the stronger one learns by teaching the less stronger. Students' choice. Students freely pick their own partner. Pick one with similar personality. Pick the opposite. Most of the time in my class, students like to pick a partner who is a friend. I find that students do better with their friends. They are comfortable with each other and can not only help each other, but also work harder to get things done. Sometimes I do random choice by letting students draw lots. It is also important to make sure students switch roles 2 to 3 times per class so that the stronger student does not dominate the session. This is an example of pair programming assignment. I selected an assignment from the textbook Starting Out with Java by Tony Geddes and modified it to be suitable for pair programming. I incorporated learning by teaching and problem-based learning into my lesson plans to encourage students to use inquiry, critical thinking skills to learn the concept of method in Java, integrate the concept into practice, and apply knowledge and skills to develop a solution to the problem. Methods in Java are commonly used to break a problem into small manageable pieces. Instead of writing one long complex method that contains all of the statements necessary to solve a problem, several small methods that each solve a specific part of the problem can be written. The assignment is test average and grade. It is perfect for pair programming. Instead of writing one main method, students are required to write 2 more methods. Student A writes a main method, validate inputs, write comments. Student B writes calculate average method. Then student A writes determine grade method, etc. Students switch roles until they finish the program. To write the program, students need to apply the concepts of methods, loops, validation, format, appropriate comments for methods. This can be overwhelming, but by implementing pair programming, students can solve problems together, such as analyzing the problem together, designing an algorithm, deciding how many methods to write, what variables and what loops to use, how to write comments for methods, etc. Students learned by explaining to each other and solve problems together. There are many benefits in pair programming. 2 heads are better than 1. More efficient, few coding mistakes, an efficient way to share knowledge. Develop students' interpersonal skills, learn to communicate, learn to explain what they know. 2 students can solve the problems faster and quicker. They learn by teaching. They don't have to wait for a teacher to come to help them. It also increases students' confidence. However, there are some concerns. For example, sometimes one student does all the work. One student dominates. Sometimes students don't get along. They don't cooperate well. But those concerns can be avoided by careful planning. Another collaborative learning is peer review. In this part, I will discuss what is peer review, how is peer review implemented, examples of peer review, benefits of peer review, what is the difference between peer review and pair programming. Collaborative learning occurs in peer review. Peer review is a learning method that involves students working in pairs to evaluate others' work and receive feedback on his own work. It is a rich learning experience. When students assess other students' work and provide feedback to them, they are building the skills to self-evaluate and improve their own work. How to implement peer review. The process of peer review is similar to that of pair programming, but there are some differences. In order to implement peer review, we need to design an appropriate project for students, set goals for the class, set rules and boundaries, teach students to listen to and respect each other's opinions, select a partner, work together, and review the work. In addition, students should be clear about what the peer review will achieve, why they are doing it, how they will benefit from it, and what is expected from them. Teachers need to explain to students objectives, expectations, and criteria for work. Develop and clarify assessment criteria by using rubrics. Provide adequate questions. Checklist may be a good way to help students to be clear of the tasks and the timeline to complete the assignment. Also provide examples to students to increase their confidence. Allow enough time and spacing for the peer review process. Observe and monitor the students' process. Coach if needed. Also provide feedback or even grade on the peer review process. This is the example of peer review questions. Students are peer reviewing another student's website creation. The project is to create a website for others. To do the project, students need to find a client, find out their requirements, criteria, and meet their needs. They are required to write a proposal describing the website, including the title of the website, the layout, how many pages, and the content. The client can be a business owner, a teacher, or their friend. When they finish the website, they need to ask their client to write them a thank you email and CC the teacher. When students publish the website, I ask students to do a peer review. I provided the questions and the rubric as guidance for them to follow and provide feedback to their partner. Students love peer review. They said that peer review encourages active learning by engaging them in the feedback process rather than just passively receiving feedback from teachers. It allows them to not only understand but also apply knowledge. The other benefits include increasing cognitive ability, such as identifying misconceptions, summarizing, and giving feedback. It helps students deepen their understanding. It encourages critical thinking and problem-solving skills. Peer review builds collaborative skills. Through peer review, students get opportunities to practice communication skills by giving and accepting feedback. Both methods are effective in computer science classrooms. I use both methods frequently in my class. The two methods are similar, but there are some differences. According to the information from Geeks to Geeks blog, pair programming is concerned with only 2 students, while in peer review, it involves 2 or more students for reviewing. In pair programming, real-time interaction between pairs takes place, while in peer review, interaction among 2 or more students takes place, but not necessarily in real time. In pair programming, 2 students are mutually responsible for the completion of their work, while in peer review, only developer is responsible for the completion of the work, and others are for the review only. In pair programming, communications and collaborations are going in the whole process, while in peer review, reviewers only see the final product. In pair programming, development effort is more in pair, while in peer review, development effort in peer review is less important, but requires time to study the final product. In pair programming, stronger student can teach the less stronger one, while in peer review, checklist guides reviewers to review the work. Another collaborative learning method is group work. Group work has been commonly implemented in computer science classrooms to motivate students, encourage active learning, and develop students' critical thinking and problem-solving, communicative, and decision-making skills. Group work is an effective learning experience in which students work as a group on the same project. Like any other collaborative learning methods, group work needs careful planning and implementing in order to achieve the result. To create an activity, the first thing a teacher does is to establish a goal for working in groups. Explain why students need to do it. Teacher needs to design an authentic activity to motivate students, encourage them to apply for their knowledge. Present the project to the students. Then group the students. Teacher can assign each student a position, or students can apply for a job they like. In cooperative learning, students help one another to be successful by working together in a team. In my AP computer science class, I used one of the program challenges from the textbook, Starting Out with Java by Tony Geddes, to develop an assessment for a real-life situation, Mark's automotive shop, to manage and monitor my students' learning. Mark's automotive shop consists of 2 services, routine maintenance and repair service and charges for parts and labor fee. Students were required to create a GUI application, which is graphic user interface, to display the total charges of a customer's service. I used a project-based learning approach to give students the opportunity to develop knowledge and skills through the project. Students were divided into 2 groups of 5 members and were required to design and write a program to perform routine maintenance and repair service. I encouraged students to treat it as a real-life project. They all had their job titles: project manager, designer, programmer, troubleshoot technician, communication specialist, etc. They took advantage of one another's strength, focused on their own interests and expertise. They worked together and performed all the tasks collaboratively, such as designing algorithms in groups, writing code from algorithm, inserting comments for the codes, finding the bugs in code, testing the code, modifying the design, rewriting the code, and presenting the final product as a group. I was actively participating. During the group work, I was walking around for guidance, support, and correction if they needed. Before the project, I designed the group work project, and after the project, I provided feedback on their finished products. Through the project, students learned to cooperate to solve problems. They learned how to communicate with their peers and with their teacher. They learned how to use computational thinking skills such as decomposition, abstraction, algorithm, etc. to solve problems. This assessment became one of students' favorites because it showcased their proficiency as a productive team member, demonstrated their effective interpersonal skills, critical thinking, and problem-solving skills. Group work is an effective learning method not only in computer science classroom, but in all other disciplines. It is a unique learning experience. Students are actively working together and figuring out problems. They learn to take and share responsibilities. They pool their knowledge, skills, and resources together to attempt more challenging work by analyzing problems and generating solutions together. They are able to apply their knowledge, acquire critical thinking and problem-solving skills in programming. They start out with assignment they have never seen before, but end up with a beautiful creation of a final product. Results show that the final products of group work have much better quality with less time to complete. In this learning model, students improve their understanding of the programming process, develop their critical thinking and problem-solving skills. Collaborative learning, whether it is pair programming, peer review, or group work, all plays an important role in computer science education. The benefits include enabling students to share ideas and see problems with different angles, breaking down complex tasks into smaller parts and combining all different skills and expertise to do more complex and more difficult work that could not be accomplished by one student. Collaborative learning requires students to go through the whole process collaboratively, such as research, looking for solutions, testing, results, just as computer scientists do in real world. The process stimulates curiosity and motivation and helps develop students' higher-level thinking, communicative, collaborative, and leadership skills. It helps develop students' positive learning attitudes. It increases students' confidence, self-esteem, and a sense of responsibility. There are many more benefits to implement collaborative learning in computer science classrooms. Therefore, it is a highly effective learning method in computer science education. I highly recommend it. Thank you for watching this video. My next topic will be teaching away from a computer, or CS Unplugged.